I'm Nitin Dahad, Editor-in-Chief of Embedded.com. In this podcast, we look at some of the trends in the world of embedded systems, both from the hardware, the software, and some of the other aspects of it, like data monetization, as well as, the trend that everybody seems to be doing right now or looking towards, which is enabling features as a service. And that obviously requires a lot of software-defined capabilities. And I'll be talking to Sumit Chauhan of CerebrumX, and he'll be talking specifically about data from the car and synthetic sensors. And what does that mean from an embedded systems development point of view? And in particular, I like the crash scenario and sort of the individual elements within that. Sumit, hello.
Hi.
From an embedded systems point of view, your focus is on using something with data that's collected specifically from automotive environments.
That's great.
And just there's so much involved. I mean, people talk about data monetization. You do a lot more underneath that to do work with the data. But tell me, from an embedded systems point of view, what are the things to be considered?
So first of all, thank you, for talking to me. And CerebrumX is in the business of monetizing data, any kind of data that comes from a connected vehicle. Now, as we grow increasingly into a world which is the ADAS world, the quantum of data that is going to be collected from the car and that needs to be taken out of the car is going to jump significantly, right? And there are different kinds of data as well, and we'll get into that. But most importantly, I think the decision the OEMs will have to make in terms of how they architect their data solutions for the car is, what do you do inside the car in terms of storing and compute? What do you do at the edge, particularly with 5G coming into its own, having a ubiquitous deployment? A lot of the functionality can be pushed to the edge. And then a large part of functionality, which is probably non-critical and can be done offline and least cost, can be pushed onto the cloud, right? Now, so how you architect and make those decisions is very important. I'll give you some insights which help you, kind of cater to that. The mission critical part, right? Things like related to ADAS, lane change, related to driver safety, and so on and so forth, will always be done inside the car because they're very time critical. There is latency involved, so on and so forth. So you want to make those decisions as much as possible inside the car. That will be the advent of what we call synthetic sensors, where a large part of the logic, the algorithms that are needed to make those decisions on the embedded side will be plugged into the car even more than what they are today. So which will lead to a jump in the compute power that is needed inside the car. Then you come to certain decisions which are non-mission critical. Like I'll give you a kind of a regular example. You have your screen, which you're using to play music or for navigation. Suddenly you feel that you want a different color to it, right? Or a different texture to that screen. You don't need to do that inside the car because it is very compute intensive. You can actually do it over the cell phone and it can be pushed over the cloud. The decisions and the configuration can happen on the edge. And you can push that back into the car because it's not mission critical. Even if it happens with a delay or a latency, you're fine, right? So that's an example, and there are many examples which will be pushed to the edge, in terms. And the other examples are V2X, where vehicles are talking to each other in terms of traffic management and so on and so forth. So all those things will move to the edge. Now, the things that will reside in the cloud are things where offline processing can happen, right? Let's say I'm collecting data on a driver for all his trips in the last 30 days. And then I need to create a driver score so that the insurance companies can define what the premium would be for the driver. That doesn't require anything which is time critical. It is not real time. So you can do it back in the cloud. So those are the kind of use cases and decisions that, the OEMs, as well as the people who are trying to monetize it like us, will need to work with the OEMs to define as to where the data processing happens.
Right. And one example you gave me earlier was about a crash scenario. And I think your specialty is in providing the algorithms to companies like insurance companies to then figure out, what are the sort of risk elements. But what are the things that your data is picking up there?
Sure. So let me first give you a scenario of how it happens today, right? Yeah. 2 cars crash, right? What you get is a police report, which basically tells you what's the damage on the car, right? What was the position of the cars, a few photographs, right? It doesn't really come even close to actually defining what was happening or what led to the crash and who was responsible. The real answer lies, in my view and CerebrumX's view, in assimilating the real scenario from 3 streams, right? The first stream is what was happening inside the cabin of both the cars or one of the cars, whoever is involved in the crash. as to whether the driver was fully functional or he or she was distracted in any way, making a phone call, was droopy because falling asleep, just not being attentive on the road, talking to a fellow passenger. We can detect all of that because there are ADAS systems that are installed inside the car, which manage and track, the driver pupils as well as what they're doing. Even if we don't have that, which is the current scenario, we can also have cabin-facing cameras, which come from third party. One of our investors is LG. They have a camera solution, so we can get a feed from them, which tells us what's happening in the cabin. The second is, what is the health of the vehicle? Was there anything wrong with the vehicle which led to the crash? Was there a jamming of the brakes? Was there something wrong with the engine itself? Was there a alignment issue with the wheels, or the steering wheel got stuck or something like that? All of the data is being collected even today, as part of the connected vehicle data ecosystem, and we can get it from the OEMs. The third is what was actually happening on the road, which is in front of you. Was it pedestrian's fault? Was it another vehicle's fault? That you can only do with a LiDAR or a front-facing camera, which is focused towards the road. As you know, with ADAS, all of that will come inbuilt in the car. But even today, you would have seen many drivers using a front-facing camera because they want to record what's happening on the car. So you take all of that, you run your algorithm in the cloud, which stitches all these three data streams together and come up with the full 360 view of what was happening. The critical thing is the data has to be collected at a much higher frequency when a crash is happening. So we have the ability, along working with the OEMs, to collect data at frequencies of 100 hertz. So, 100 times a second, basically. Whereas normal data is collected once a second, 1 second intervals. But in a crash scenario, 10 seconds before and 10 seconds after, because you can sense it, the OEMs start collecting data which is at 100 hertz. It's 100 times more frequency, and then the analysis becomes more comprehensive.
So we're really heading towards, the trend is towards like using more of the data, but needs people, companies like yourselves, not just yourselves, but companies like yourself to help OEMs figure out how that data can be used.
That's correct. I think credit to the OEMs is they've been upfront and they've made an investment into creating the data ecosystem on their side, on the embedded side, to enable data to be collected and taken out of the car into their cloud. The problem that we came up with and around which CerebrumX was formed was, how do you create value out of that data? It is not good enough for verticals like insurance or fleet or aftermarket like warranty supports and extended warranties to just give data to them. They actually need insights which are meaningful to that particular vertical. And that's where CerebrumX comes in and provides those insights on top of the data, which helps the OEMs to get a better margin on the data that they're collecting.
Well, Sumit, thank you very much.
Thank you. Pleasure.
That brings another episode of EE Times Current to its end. Thank you for joining us. Today's highlight was Electroda, where engineers go for expertise. EE Times Current is produced by EE Times. The segment producer was Lady Maya Kane. Today's episode was engineered by Taylor Marvin from Coop Studios and Lady Maya Kane. I'm Eric Singer. Thanks for listening.